All right, hello everyone. I'm going to be telling you a little bit today as a review of Ohm's law and Watt's law. Before we start, we need to look at what are the terms that we need to know with regard to using Ohm's law or Watt's law. First is you need to know that I is always amps, and amps and current are the same thing. So whenever you see amps or whenever you see current, you're going to use I in the equation. Whenever you see R is always ohms and resistance. Ohms and resistance are the same thing. So whenever you see the words ohms or resistance, you're going to use fill in that value for R. Next, we have V. V is always volts and only volts. So whenever you see V, you're going to use the value, or whenever you see volts, you're going to use the value associated with that. Last week, we introduced P, and P stands for power or watts. Okay, so whenever you see watts listed, you'll fill that value in for P. So what are the two equations that we have? Well, we have Ohm's law. Ohm's law can be written as V equals I amps times resistance. Okay, it can also be written as V divided by I equals R. Or thirdly, it can be written as V over R equals I. So if you have the amps and the resistance, you can figure out the volts. If you have the volts and the amps, you can figure out the resistance. If you have the volts and the resistance, you can figure out the amps. So you're always looking for, what do you have? Do you have, if you have V, I, and R, or if you have two of those three, you can figure out the third missing one for Ohm's law. For watts, you can, it's slightly different, but very, very similar, and that is P, or power, or watts, equals V, volts, times amps. Also, this can be written as power over volts equals amps, or P over I equals volts. Okay? So what are the key things when you are solving these equations that you need to look for? On some equations, you'll use Ohm's law. On some equations, you'll use Watt's law. The key thing that you are looking for is one word in each. If you see the word resistance, you are going to use Ohm's law. If you see the word power, you are going to use Watt's law. Now, there are some other correlations between these two equations in which you can actually interchange things a little bit. But for our purposes, we're going to focus on just these two. Whenever you see the word resistance, you use Ohm's law. Whenever you see the word power, you use Watt's law. So here's an example. All right, let's go to this page right here. Okay, on this page, you see the same equations that we've kind of already been talking about, and we're looking at a real world example. It says, suppose you wanted to figure out how many 500-watt lighting instruments you could plug into a circuit without blowing a fuse. So what we need to figure out is what's the maximum amount that we can put into a lighting fixture. So you don't want to blow. This is like when you're plugging in Christmas lights. You have to be careful not to string too many strings together, or you'll blow out the Christmas lights. So what we know is that most homes have 15 amp circuits. So at MassArt, most of the circuits are 20 amp circuit breakers. So the total power would be 20 amps times 110. So that means that they are 2200 watts. So we do the volts times the amps right here, 110 times 20, and you get 2200 watts. Volts times amps equals watts. So you got 110 volts coming in, you got 20 amps in the switches there, or in the breakers there, so that gives you a total of 2200 watts. Now, what it's asking you is, the question is, how many 500-watt lighting instruments can go into the fuse? So if it can hold 2200 watts, I'll go ahead and flip back to the iPad here, make this a little smaller so we can see the two side by side here. If we have 2200 watts total, then you can always handle up to 2200 watts. So what we're looking at is how many 500-watt fixtures will fit into 2200. So it's a simple division problem. If there's 2200 watts, then we can fit in 4. Now, there's going to be 200 watts left over that you got to play with. But if you added another, then that would be 2500 watts, and it would blow the switch. So Another example is, let's look at the difference between ohms and watts. So I'll make this a little bit bigger one more time here. Let's say that I have a switch that has, or a device that requires 13 volts and let's say 1.2 amps. Okay, so we know that amps equals I. So if we have volts and we have amps, there's two things I can figure out. So I have to look at what the question is asking me. So I know volts and I know amps. I got 13 volts and 1.2 amps. If I want to know what is the resistance, then I'm going to use Ohm's law. If I want to know what is the resistance, I need to use Ohm's law. And Ohm's law states that V equals I times R. Well, I don't know R here, so I need to do V divided by I equals R. Okay, and so what you would do then is 13 divided by 1.2. I'm going to use my quick calculator so I get a more exacting one on this here. And 13 divided by 1.2 equals, that means approximately 10.8 ohms of resistance, 10.8 R. All right, so you would need to make sure that you get these three things when you write your answer. Now, if I had this exact same question here, and now I can erase something on it, and let's go back and say, instead of asking me for the resistance, this time it may be asking me for the power. So if the question is, what is the power produced? Now I'm going to use Watt's law. If we go back to Watt's law, we go back here and we see that watts is power equals volts times amps. So since we're asking for power and not resistance, we use Watt's law. So in this case, what is power? That means 13, or sorry, I guess I can put that Watt's law on there. So P equals volts times amps. So P equals 13 times 1.2. And if I get on my calculator again real quick, I have 13 times 1.2 equals 15.6. So P equals 15.6. Eighth graders, please remember that you need to have step one here, get it in purple here, step 1, step 2, and step 3 whenever you are solving this. So quick review. We have Ohm's law and we have Watt's law. Ohm's law, V equals I times R. Watt's law, P equals V times I. The keywords that we're looking for. If we have the word resistance in the problem, you use Ohm's law. If you have the word power in the problem, you use Watt's law. So to solve, we go here. What is the resistance? I'm going to use Ohm's law. What is the power? I'm going to use Watt's law. That should cover it.